Think about the last time you felt truly physically cold. Not uncomfortable cold, the kind that makes your chest seize and your thoughts slow and your body begin to argue with your decisions. Now multiply that feeling by the knowledge that outside your suit, outside the thin aluminum walls of your habitat, the temperature is negative 80 degrees Celsius on an average afternoon. Not at night, not in winter, on an ordinary afternoon, in what scientists classify as the most habitable region of Mars. And you chose to come here. You trained for years. You left Earth willingly. You told your family it was worth it. The question that nobody back home is asking, the one they are too excited to ask, is whether any of that was true. Mars is not a destination, not in the way we use that word for cities or continents or even oceans. The average distance between Earth and Mars is approximately 225 million kilometers. That number is technically accurate and almost entirely meaningless until you translate it into something the human nervous system can process. Light moving at 300,000 kilometers per second takes between 3 and 22 minutes to cross that gap, depending on where each planet sits in its orbit. A distress signal from your habitat, traveling at the speed of light, takes up to 22 minutes to reach Earth. The response takes another 22 minutes to return. 44 minutes of silence between crisis and acknowledgement. 44 minutes during which you are, in every operational sense, completely alone. No rescue mission can bridge that gap in time. No supply shuttle is waiting in orbit. The minimum travel time between planets using our current best propulsion is approximately 7 months. One way, you do not call for help on Mars. There is no help. The surface area of Mars is 144 million square kilometers. That sounds vast until you learn it is roughly equivalent to all of Earth's dry land combined, packed onto a planet with no oceans, no breathable atmosphere, and a gravity that pulls at only 38% of what your skeleton was built for. Your bones, over months, will begin to lose density. Your cardiovascular system will weaken. Fluids will shift toward your skull in ways that damage vision. The human body on Mars is not adapting. It is deteriorating slowly, consistently, and without dramatic announcement. Mars does not feel hostile. That is what makes it dangerous. It feels still. You need to breathe. That is not negotiable. Mars has an atmosphere. Scientists know this because they can measure it. What they do not say in press releases is that this atmosphere is approximately 95% carbon dioxide, with a surface pressure less than 1% of Earth's. Breathing unfiltered Martian air would be physiologically equivalent to breathing in deep space. Your blood would attempt to boil. Your lungs would collapse outward. You would lose consciousness in approximately 15 seconds and be dead shortly after. Every molecule of oxygen on Mars must be manufactured, stored, and distributed by machines. Machines that require power. Power that comes from solar panels or nuclear reactors, both of which can fail. The moment your oxygen generation system develops a fault you cannot repair, a seal, a valve, a corrupted line of code, the countdown begins. Not metaphorically, literally. You have hours, maybe less, before the air inside your habitat becomes unbreathable. But that is not the worst part. The Martian surface is saturated with a class of chemicals called perchlorates. These are toxic oxidizing compounds present in the soil at concentrations between 0.5 and 1%. Perchlorates disrupt thyroid function, compromise the immune system, and are classified as probable human carcinogens. They are not contained in specific regions. They are everywhere, in every handful of dust. And the dust on Mars does not stay still. Martian dust storms are among the most spectacular and lethal phenomena in the solar system. They can grow from regional events to planet-encircling systems in a matter of days. The storm of 2018, observable from Earth with amateur telescopes, covered the entire planet for months. It was responsible for ending the Opportunity rover mission, a machine far less fragile than a human being. During such a storm, perchlorate-laden dust infiltrates every gap, every vent, every imperfectly sealed joint. It is not merely unpleasant. It is a slow, systemic poisoning delivered by the planet's own weather. And then it gets worse. Mars does not have a global magnetic field. Earth's magnetic field is generated by its liquid iron core and acts as an invisible shield, deflecting solar wind and cosmic radiation. Mars lost its magnetic field billions of years ago when its core cooled and solidified. What remains is almost nothing. What that means for you is that the full force of solar radiation and galactic cosmic rays reaches the surface with minimal obstruction. The annual radiation dose on Mars is approximately 0.67 sieverts, compared to Earth's average of 0.03 sieverts. Long-term exposure dramatically elevates the risk of cancer, cognitive decline, and cellular damage to organs that cannot repair themselves indefinitely. Shielding helps, underground habitats help more, but shielding cannot be everywhere. Every EVA, every excursion outside the habitat accumulates dose. You are not in danger. You are simply being irradiated at a rate that will, statistically and medically, shorten your life. Physics does not care about your mission objectives. NASA's Perseverance rover, currently operating in Jezero Crater, carries an instrument called MOXIE, Mars Oxygen In Situ Resource Utilization Experiment. Its purpose is to test whether oxygen can be produced from the Martian atmosphere by splitting carbon dioxide molecules. In 2021, MOXIE successfully generated approximately 5 grams of oxygen, enough to sustain a single human for roughly 10 minutes. That is the current state of the technology. One rover operating in ideal conditions, producing 10 minutes of breathable air. Scaling that process to sustain a crew of 6 for a single year would require equipment weighing thousands of kilograms, operating continuously without failure, drawing power from systems that must themselves remain operational through dust storms, temperature extremes, and the general entropy of machines far from any supply chain. SpaceX's Starship architecture envisions landing the first humans on Mars sometime in the late 2020s or early 2030s. The technical ambitions are real and serious, but the vision of a self-sustaining city of 1 million people, proposed by Elon Musk, requires not merely engineering breakthroughs, but biological ones. Agriculture on Mars, even in pressurized greenhouses, faces light levels 30% lower than Earth, soil chemistry that is toxic without extensive remediation, and radiation that penetrates surface-level structures. The science is not discouraging because scientists lack imagination. It is discouraging because reality imposes constraints that imagination cannot dissolve. Here is what people do not say aloud in the public conversation about Mars colonization. The first settlers may not be coming home, not because the mission is poorly planned, because the physics of orbital mechanics create narrow windows for return trajectories, called launch windows, that occur approximately every 26 months. Miss the window due to equipment failure, medical emergency, or the slow accumulation of problems that define any long-duration mission, and you wait another 2 years. 2 more years of radiation, 2 more years of muscle and bone deterioration, 2 more years of psychological isolation in a habitat approximately the size of a shipping container, shared with the same small group of human beings on a planet that does not offer you a single natural comfort. And if the habitat systems fail catastrophically, the pressurization, the power, the oxygen, there is no emergency evacuation protocol that functions on Mars the way it does on the International Space Station, where rescue is hours away. On Mars, it is not hours, it is months. The return vehicle, if it exists and is fueled, requires a launch window that may be a year away. Survival, in that scenario, is not a question of courage or resourcefulness. It is a question of whether the universe decides to cooperate. It rarely does on schedule. Step back then, not from the planet. From the ambition, there is something deeply human in the desire to leave, to plant something new in ground that has never known a footprint. Exploration is not merely strategic, it is emotional, almost spiritual. It is how our species has defined itself across every century of recorded history. We go because staying feels like surrender. But Mars forces a question we have not yet learned to sit with honestly. What does it mean to survive somewhere that does not want you? Not in any conscious sense. Mars has no malice. But indifference at this scale and this distance is its own kind of hostility. A planet that will not provide air, will not protect you from radiation, will not grow food without intervention, will not let you leave on your own terms. That planet is not a new home. It's a test of whether humanity has earned the right to exist beyond the only world that was ever designed to hold us. We did not design Earth. We simply fit it imperfectly after billions of years of biological negotiation. Mars offers no such negotiation. It will not meet you halfway. It will not adapt to your needs, your biology, your grief, or your hope. You adapt entirely, permanently, without guarantee. And perhaps that is the most honest thing anyone can say about colonizing Mars. Not that it is impossible, but that the cost of making it possible may be a version of humanity that is no longer recognizable as the thing that chose to go in the first place. We look at Mars and see potential. Mars does not look back.